All right, what up, everybody? This is Mr. Stan coming at you with another physics video, and this time we're looking at examining a velocity versus time graph, specifically one where there's more than one type of motion. So the velocity in this graph, goes up, then it stays the same, then it comes back down, right? So what does exactly that mean? Well, it doesn't mean that it goes forward, stops, and comes back. Okay, that's the position graph. All right, so this is something different. This is showing that it starts with no velocity. It speeds up until it gets to 2 seconds. Then it keeps a constant velocity, right? And then it slows down, right? And how do we know it slows down? Because it's getting closer to zero. So let's go through these kind of segment by segment and see exactly what happens. And we're using two tools. We're using the tool that we know that the slope of a velocity graph is equal to acceleration. And also we know that the area underneath the velocity graph is equal to the displacement. So we're going to be able to use that information to find what exactly is happening here with numbers. Okay, so we'll split it up into the three segments that you see. First from 0 to 2, because that's when the line is going up, right? And if you find the slope at that point, it goes up 10 over 2, then the slope is equal to 5, 10 divided by 2. That means that the acceleration is going to be 5 meters per second squared, right? You can also find the area. The area of a triangle is just 1/2 base times height, so one half of 2 times 10 gives you 10. That means that during these 2 seconds, while it was accelerating at 5 meters per second squared, it traveled 100 meters. Okay, for the next second, from between 2 and 3 seconds, there's zero acceleration because the slope is 0. Right, so it's moving at a constant velocity of 10 meters per second. So this is not slow, all right? This is actually the fastest that it goes during the whole time. It's just not speeding up or slowing down, and that's why you have a flat line. If you find the area of that, there's the base of 1, a height of 10, so that's area of 10. That means that during this 1 second here, it moved another 10 meters. So in total, from 0 to 3 seconds, it's moved a total of 20 meters, okay, because 10 plus 10. And for the final seconds where it's slowing down, the slope is negative 2.5, okay, because it goes down 10 and over 4. And if you divide that, you get negative 2.5. And we can find the area of this triangle here. 1/2 base times height would be 1/2 of 4 times 10. And we don't use the negative numbers in finding the area. Okay, so this is 20, then it'll be 10 plus 10 plus 20, or 40. Okay, so this thing has gone 40 meters. So that's how you find out the acceleration and displacement when you only have a velocity graph. Okay, here's an example. A squirrel starts from rest and accelerates 3 meters per second squared for 3 seconds. It then keeps that speed for 5 seconds before stopping suddenly. How far has it gone? Okay, so we're only told how fast it's going. We're not told how far it went, and that's the goal. So first, we'll use the information they give us to make the graph, right? It accelerates 3 meters per second squared for 3 seconds. So that means that every second that goes by, the velocity goes up 3. So at 1 second, it should be a velocity of 3. After 2 seconds, it should be a velocity of 6. And after 3 seconds, it should be a velocity of 9. Okay, then it says it keeps going that speed for 5 seconds. So for the next 5 seconds, you just have a flat line because the velocity doesn't change. Okay, so now we just find the area underneath the graph. The first part is a triangle. Okay, and 1/2 base times height, it's 9 times 3 divided by 2, and that would give you 13.5. And the next part of the graph is a rectangle, which would be 9 times 5, or 45. If you add those together, then you get that the squirrel traveled 58.5 meters. So we're able to start with velocity information and figure out where something is, right? And that's the goal of this exercise. All right, I'll see you all in the next video.